So you see now my slides?
Yes.
Okay. I was not asking, but thanks for confirmation. So true story from a scientific and practical perspective, because as I said, we had unique opportunity at my university to actually see what happens when medicine meets data science. So let me just start how it all started. So some group of data scientists, some group of scientists who are familiar with programming, with numbers, visited our university. It was quite a long time ago. It was about 2015. And at first, nothing happened. I was by accident, I somehow found myself on this meeting. I don't remember why, but I was fascinated by their offer. I was fascinated by data science. However, our environment, our community, medical community, was not that interested. They thought this is something like more sophisticated statistics, but maybe that's not the most important thing to look for in the future. So after a year or two, the professor with whom I'm cooperating, who is now our rector, Professor Ponikowski, he became vice rector for scientific activities. So as I'm working with this professor since, I don't remember, maybe 2005. So I just knew that this person will appreciate this kind of opportunity. So I just went to the professor and I told him that there are a group of people here and I think they have very interesting ideas for us. So we decided together that we need to do something. We just can't, we have to do something together. We have to try to somehow combine our data with something which can actually bring more knowledge from this data. So the first decision was to do something together, but of course, it's always a question of money, of financing. So we were looking for some contest for which we can apply to get financial support to cooperate. And we found a call under so-called the twinning initiative. I will tell you about this later. And we started preparing the idea, the submission, the proposal. And first submission took part in November 2017. But at first we were rejected. And it was very funny because we got great scores. They thought the committee says that our idea is great because we just decided to describe that we would like to combine data science with medicine just to have a knowledge transfer in this area. But they decided that we will not get the money because there are no females in our group. I mean, I was there, but among our experts, data scientists, at that time, in fact, there were no females. So European Commission, as usual, just thought that it can't be, they can't support this kind of initiative. So we needed to correct the proposal. And a year after, we decided to submit this once again, because as I said, we received great high scores, almost maximal scores. Of course, there were some additional females in our proposal. So as a result, it was a success. In April 2019, I received information that European Commission decided to support our idea to cooperate with data scientists based on medical data. Due to some, let's say, personal matters, we decided to sign the agreement as late as possible. So in the beginning of 2020, we started the project. And we've finished this project, in fact, a month ago, because it was a 3-year project according to the call. And that was the project which was mentioned before I started today. So this is Heartbeat 4.0, which is, as probably you all know, it's like a number symbolizing revolution, digital revolution. And our subtitle was Application of Innovative Medical Data Science Technologies for Heart Diseases. Why heart diseases? As it was also mentioned, I work in a physiology department, but my initial scientific activity was linked to cardiology. So I'm familiar with cardiological data, and people from cardiology, we are still cooperating. So we decided that this is the most promising area of cooperation. We received funding from European Union's Horizon 2020 Research and Innovation Program, and that's how we started. So what was the idea of the project? So according to what the twinning is about, the aim was to upgrade the research profile of the leading institution. We were the leading institution. Wrocław Medical University was a leading institution, mainly Institute of Heart Diseases as a main subunit for this project. And this upgrade was planned to be done using knowledge transfer. We decided that after the project, we need to have a team of people, medical people with new skills. We called the CMED, Center of Excellence in Medical Data Science. And we knew that we don't want medical people to be able to actually programming, to write a code. It's not the aim. We just wanted to have a team of people who will be able to cooperate with data scientists. This will help us to start new type of research. So, as I said, twinning projects are all designed to support the knowledge transfer. So there is no actual research, no data collection, no examining patients, but we have one institution who is a student in this model and few institutions who are so-called excellent partners, who are our teachers. So the leader of the consortium in this case was a student, and it was my institution. So some people from Wrocław Medical University were learning during the project, and excellent partners were the teachers, and we had 4 excellent partners. I will shortly sum up what were their tasks for us. So we cooperated with Wrocław University of Economics and Business and 3 universities from abroad, from two universities from Germany and 1 university from Prague. So the first partner was responsible for showing us the basics, the fundamentals, how we can explore the data, what we need to know to be able to select the correct method in this new group of methods. What are the available algorithms, machine learning algorithms? What are the available software packages? And we also were getting familiar with some experiments in selected software. And additionally, we were also familiarized with the questions of data security, privacy issues, which is very important in health data. So that was the first part of the course. Then we had some workshops or some knowledge from Technical University of Dresden, more biomedical examples, so more concrete examples, including data management for clinical trials, for ECRFs, so more concrete medical examples from the center, who is more, as compared to us, is more experienced in how we can apply data science to medicine. Lipsk helped us with databases and more, how to say, sophisticated subtypes of machine learning techniques, and how we can design the database for this kind of approaches. And the last partner, Prague University of Economics and Business, they showed us a slightly different methodology of data mining, also some details related to databases and how we can actually find new knowledge from the old data. And we can sum this up and say that during 3 years, we had more than 60 lectures, workshops, laboratories, Initially, we were planning to do this during travels, but as you probably remember, in March 2020, there was the outbreak of the pandemic, so all the travels within Europe were limited. That's why scientific visits were limited to short trips. We started the trips right after reducing the restrictions, so it was last year after March. But everything actually was doable online, and all the classes took part. It was even beneficial for us because we could record a lot of courses, and they could be somehow watched by doctors during their work when they had like night shifts. So we were not somehow limited by the timing of the courses. We also had many individual consultations. So our experts from the four excellent partners institutions supported us with proposing ideas for PhD thesis or some scientific papers which we together written. We also had a summer school, so it was like an intensive 3 years of trying to transfer the knowledge from data science to medicine, and the other way around, to be honest, because data scientists also, they learned a lot from us about medical data. So I would like to sum up the observations, the first observations from the perspective of this data scientists group, IT perspective. First, what they observed, it was that our data is very messy. There are many empty boxes, many imperfections, which was surprising for them, and it was hard to actually find a common language to agree why the data looks like they look. Also, they were surprised that we, I mean, medical people who sometimes do something which we can call science, we think that a single Excel sheet is a database for us. So they were surprised that we use that big names for that poor, messy data that we have. And also, they had to explain to us, I mean, to the medical community, that they are not magicians and they can't just, you know, find something in the data, no matter how is the shape of the data, what is given to them. But our important conclusion after this first weeks or months was that they saw that they want very often to know, for example, why a client will buy a particular product, because probably you saw that our partners were mainly from the economic area. So if they would like to find some rules for clients' behavior, and at the same time, we want to find some rules for patient behavior, for example, why some patients are again and again hospitalized, why they come back, what is the pattern behind it. So that was the point where they decided that this is our common point. That's where we can start looking for something which will be beneficial for both of us. And at the same time, medical perspective and our observations was that, okay, our data are not perfect. We have many empty boxes in our databases, but that's the reality. Yes, because medicine it's not just a computer program. There are people, there are missing data, there are events because of which we can't have data. So that's just the truth. And we can't create artificial perfect data just to, to follow the expectations of data scientists. So we needed to agree on the fact that medical data are not perfect. We realized that, in fact, the source data, like the data from medical equipment, that's something which is the most attractive element for data scientists. So after this meetings, after the discussions with data scientists, we realized that we should have more data than just our poor Excel sheet, and that will be probably the data that they are looking for. And also, if they are not magicians, we need to actually be able to follow the logic which must be there to create the questions to which they can answer. So that was I think that the biggest challenge and the biggest part of learning here. And we also observed the same. So if we want to know why and which patient will be hospitalized more than once, for example, or more frequent, and at the same time, they are looking for some patterns to explain why some clients will buy particular products more than once, that's something which, from the logical point of view, is very, very similar. So we can try, for example, to use the data to find some patterns according to which we can predict events which are important, for example, for us in the medical context. So I will show you some examples of it. Because we all know that medicine loves tests and classification. Each time when you are doing, I don't know, blood test or any kind of test, the doctor will tell you that your value is low, high, normal, abnormal, and so on. So in fact, there are a lot of data-related there is a lot of reasoning which is based on data. And always there are some ranges we need to refer our results. And the definition of diseases for medicine is very often a set of results which are classified as low or high and so on. And this is, it's clear, it's very simple, as long as we just interpret a single patient and individual. But hey, probably we can do something more with this. Let's imagine that we have two features. We measure two features in a patient and both can be classified as high or low. So we have, in fact, 4 groups there: low, low, low plus high, high plus low, and both values low. This is easy. It's not a big challenge. We don't need data science to be able to find such subgroups. But let's even think of still 2 features, but they have also the medium value, normal range, which also can be interpreted. So it's harder. It's not that clear. We have multiple grouping. Is it really relevant for medicine to divide groups in this? So it's not that easy. But on the other hand, we still have those results. If you do blood test, you always have more than 10 results. And for each result, you have precise information if this is high or low, high or low. So we can imagine that we would like to see all those parameters at the same time, and based on them analyzed together, probably we can find out something which is valuable from clinical or scientific point of view. So we can decide to, for example, group people or define the subgroups based on 2 or 3 or more features analyzed together. And that's something which is really hard even to imagine when you think of how we could actually process this in our brain. And that was the first moment when data science helped us, because they show us clustering. What is clustering? Clustering is a method of grouping unlabeled examples, because we can calculate mathematical similarity between them. So we can use raw data and find out the groups which naturally are there. We don't need any ranges. We should not define any cutoff points. Just we will read what the data is showing us. So we can find subgroups within data which are very messy. And the subgroup, so the cluster, will be less heterogenic or less variable than the whole data set. So still we can find some, some order in a very variable data set. So that was something which we decided is really very tempting, and it can have some clinical value for us. But remember that it was a challenge for some of the doctors that for this approach, we will not use any expectations. So we will not define some value as high or low. Just let's see how the data are associated with each other, where they are, where are the points characterizing the patients. And using clustering, we could actually find groups which are there, but the traditional classifications are not helpful with revealing such division. And when I was discussing these possibilities with the medical doctors with whom I'm working together, we saw that that's one of the examples of our papers, scientific manuscripts, which we have written during the project. So the doctors very often say that they know that the patients are different from each other, but the traditional classification is not the answer of this variability. So there is some intuition, and the doctors, they feel those differences, but up until this cooperation with data science, it was not clear for them if this is real difference there, or it's just their intuition, their suspicion that something can matter. So this is the first example shows that if we collected many parameters characterizing patients with acute heart failure, this is a very serious condition, life-threatening condition, which is happening from time to time in patients with chronic heart failure. So our team collected a lot of data and applied clustering algorithms, and they found that, in fact, based on 63 important variables, we can find 6 different clusters. And each cluster can be characterized by a few features typical for a cluster. And what was important here, they call it phenotyping. So looking for types, looking for phenotypes in a subgroup which looks like homogeneous, but it's not true. So the phenotypes there were actually different from each other. And what is very important, further analysis showed that clusters revealed using this method differ from each other in terms of survival, which is one of the most important parameter in cardiology. So that was one of the really important points of our cooperation. For me, this idea of clustering was even more important because apart from being a biologist, because I'm a biologist, I teach physiology, but also my second education, my second faculty is psychology, and very often my studies are focused at behavior of patients. And if you want to study the behavior, you need to use some measures, typically some surveys. And the analysis of surveys is really very limited in medicine. We just look for a result and probably look for a correlation with the other result. So for me, it was not enough. And I decided to apply analogic, similar way of thinking to the data, which is interesting for me. So, sorry. In the paper entitled Patterns of Locus of Control in People Suffering from Heart Failure, I will not go now into details because it's really very complicated, but I used one psychological test which is able to give me 3 independent scores. Those scores reflect the beliefs about health in a patient. So patient can have 3 different beliefs, and each belief can be more or less represented by the patient. If the score is higher, it means that this belief is more characteristic for the particular patient. If we have lower score, it means that this is not that typical for a patient. What is important, we know that those beliefs are responsible for health behavior. So some people have beliefs according to which they will follow the recommendations from doctors. The other beliefs are typical for people who ignore the recommendations from doctors. And in cardiology, it's very important to actually catch this relation, because if the patients are not following the recommendations, the whole treatment does not make sense. And as long as you have a single patient and you see the 3 results characterizing this one person, it's really easy, because you can predict, okay, so if that guy has this or that beliefs, we can expect that he will totally ignore what we are telling to him. But this is not enough, because in medicine, you rarely have time to interpret a single pattern responsible for the behavior and propose some individual way of education, for example. So my idea was to apply clustering for this kind of test to find subgroups of people who will be similar to each other in terms of those beliefs. So we can create education for a subgroup characterized by this version of beliefs, which will be different and dedicated for this subgroup, without trying to educate all of them in the same way, which is not working. To be maybe more clear, I will show you that we have those 3 beliefs. This what you see on the left, my left. So the biggest graph shows a result from one person. So you can measure the level of, let's say, green beliefs, yellow beliefs, and purple beliefs. And the green beliefs are that I decide about my health. Yellow beliefs is that medical people or some caregivers, they decide. I have not that big portion of decision on my side. And the purple color symbolize beliefs that, in fact, it does not matter what I do. It's a question of God, fate, bad luck, and so on. So people, each one of us, each person can be characterized by 3 types of beliefs on a different levels. So if I measure this in a group of patients, then I can group them together based on 3 results analyzed at the same time. And you can see on the right part of the slide, for example, you have the 9 clusters in general, and those 2 clusters which I marked using red are different from each other, because you can see that the beliefs in myself, my decision, my individual influence on my health is the lowest in the cluster on the right, and is quite high in the cluster which is near to the middle of the slide. So I can imagine that for the people from the cluster with low green level, I should prepare something which will probably provoke them to believe in their influence and so on. But for the people in the cluster with high level of green beliefs, there's no point to convince them that they can help themselves. I should rather focus on the content of what they should do. So this is just one of the examples how this clustering may be helpful to actually see the message from psychological tools applied to patients, which will be different from just seeing correlations with other parameters. For me, this is highly practical, and based on this kind of analysis, we can actually act on patients, which will be, of course, a subject of our future studies. So we are, based on this kind of analysis, you can prepare slightly more personalized message to some groups. We can find the groups with the most promising or the least promising set of features and treat them in a special way, treat this as like specific therapy, additional behavioral therapy, as something additional to the traditional treatment. So that was another example. We were, during our project, we were generally analyzing how data science may help with the management of cardiac diseases. That's another paper which we succeeded to write together, just a review of approaches in heart failure. We also prepared some theoretical papers together, just showing some other algorithms here, association rules, which is something different from clustering. Again, we showed how it may actually refer to medical data. And other people from medical university, not only cardiologists, also used, here we have decision trees, which were used by Mariusz Bromke, his biochemical doctor. So he was trying to find some profiles of free fatty acids, which was something new, finding those subgroups using this technique. Here we have also examples of finding out other risk groups with in the context of COVID-related behavior. And here another analysis with renal function, which is very often worsened in patients with heart failure. So another group of parameters added to the traditional group, which also helped us to see new relations, and it was helpful to understand the background. We also analyzed huge survey, huge data set from the surveys about what medical students think and how it affects their behavior in the context of vaccination. So not only cardiology, as I said, and another context with blood pressure, so more cardiological context. So what I wanted to show to you today is that we were looking for the scientific but also practical answers to our questions around us, as soon as we just got the idea what the data science can do in our context. And what were the most important observations after the initial ones, which I presented, was that this is not easy to combine medicine with data science, and there is more than one reason why it's not easy, but it's of course fascinating, and this is the future, so we will not stop doing it. The professionals, namely medical doctors and data scientists, they use totally different language, and they are very busy. So from the practical point of view, it was really hard to even find the time in the doctor's schedule to present them this knowledge. What is also very important, and this is one of the most important message, I think, related to this question, is that we need to remember that data science is an area originated from environments which are digital by their nature. For example, financial systems from banks or online services, online shops. Medicine, by its nature, is not digital. We have still many parameters which are not reflected by the data that is ready to be somehow treated with the algorithms. So if we want to apply artificial intelligence to medical data, we need to make sure that the digitalization is done, and we need to make sure that this is done correctly. So before we will say that artificial intelligence is stupid because it says stupid things to us, we need to be aware that we still do not have the data sets which are representative for medicine. For example, there are some areas of medicine which are digital, like, for example, imaging. And within imaging, we have many applications of data science, and it's successful. But this is a small fragment of medicine. If you will now recall your own visit in the doctor's office, still there is many things which you will just get on paper or CD or I don't know, but it's still not collected in a data set which can be just easily treated using data science. And the next step in this context is that this digitalization of medical data must be done in a way which will ensure the quality of the data. If we will not be able to confirm that the data that we have is reflecting the reality, AI will not help us, because this will, I don't know what this will show, but the first step which we need to do is to take care of the data which we are serving to the algorithms. Data scientists can only say that the data is prepared to be analyzed or not, but they do not know the truth. So medical people must be able to actually detect the sources of the data and be able to confirm that the database, which is prepared based on this, it's actually similar to the reality, as similar as possible. We as university are now trying to share our observations. First step was to start an optional course, the course for medical students, Introduction to Practical Implementation of AI in Medicine. That's something which I decided to do last year, and I can start this course as a teacher. I will start it within 2 weeks. We have this for Polish speaking students and English speaking students, and I know that there are some important steps on slightly higher level to include such course to the obligatory part of medical course in our university, because now it's only optional. But I know that there are some decisions already made to include this program as obligatory element. We also got the financial support to continue the exchanges of students between Wrocław Medical University and our partners. So we still will have some exchange. And also we are planning to propose a commercial training and offer this to people from, for example, IT or other communities, also medical community. But of course, we will not do the course about AI in medicine, because no one is interested, to be honest. But we want to show, we would like to provide a basic course which will help the people to be familiar with the data, to be able to start working with the e-health. Because before, there is some question, I guess, but it's, I think, the last slide, so that just let me finish. So we want to propose a training for the external environment, some people from probably IT companies. So if they want to actually start with the e-health, we can help them, because we know how we can describe medical data to them to make it work. And also we can address such a training to medical doctors who would like to be a consultants, cooperating with the IT companies. And yes, that's just the link for the project. And I want each of the participants just to, if you want me to go back to any of the slides, just let me know. I don't know if this was long or short. I have no idea. So, but that's all.